Hello there, welcome to the October 2020 applied paper. Here we're on the final question of the paper, the fifth mechanics question, question 10 overall. A small ball is projected with speed u meters per second from a point O at the top of a vertical cliff. The point O is 25 meters vertically above the point N, which is on horizontal ground. The ball is projected at an angle of 45 degrees above the horizontal. The ball hits the ground at point A, where AN is equal to 100 meters, as shown in figure 2. The motion of the ball is modelled as that of a particle moving freely under gravity. Using this model, show that U equals 28. Okay, so the key to this question here is that we're going to be reaching A with a common value of U in the horizontal and vertical components, but we're also going to reach A with a common value of T for both the horizontal and vertical components as well. So let's do the horizontal component first. That's the easier components because we'll have no acceleration in the horizontal components. So we can just use, for horizontal, we can just use distance equals speed times time. Distance equals speed times time. So the distance that we want to travel is 100 equals the speed, which is going to be u, and then when we resolve it, let's resolve it upwards and downwards. This is going to be u cos 45. This is going to be u sine 45. So it's going to be u cos 45 times by t. Okay, so let's just start to rearrange this. Cos 45 is 1 over root 2, so it's going to be u over root 2 times t. So then let's work out what t is equal to. It's going to be 100 root 2 over u equals t. So in the next part, where I start to do vertical suvat, I'm going to use my time value t is 100 root 2 over u. Sounds like it'd be complicated, but actually it does help us work out that u is 28. So let's do the distance first for suvat. The displacement is going to be minus 25. The initial speed u is going to be u over root 2 as well. That's going to be u sine 45, so u over root 2. V we're not really interested in. A is minus g, and t is what we've got t to be above. T equals 100 root 2 over u. So it's going to be s equals ut plus half at squared. So it's going to be minus 25 equals u, which is u over root 2, times by 100 root 2 over u, plus, that should be a minus because it's minus g, so it'd be minus a half of g times by 100 root 2 over u squared. Okay, so let's see what we can do here. Now this u cancels out with that u, and that root 2 cancels out with that root 2, so we've got here minus 25 equals 100 minus, now let's expand the brackets here. When we square the root 2, that will give us 2. So actually that will cancel out with that perfectly. And it's going to be 100 squared. So that's going to be 10,000 g over u squared. Okay, so let's now rearrange this a little bit. It's going to be 10,000 over u times u squared times g. Let's move that negative bit onto the left, move this minus 25 onto the right, so that's now 125. And let's now multiply the u squared onto the other side, so that's now going to be u squared over there, divide by 125, so it's 10,000 over 125 times g. That's our value for u squared. So let's do that on the calculator then. 10,000 divided by 125 times 9.8, and that gives us, exactly 784. So therefore when we square root u, square root answer, u equals 28. Exactly. I thought it was going to be some rounded decimal. U is exactly 28 there. So that kind of reassures me that I've done the working right here. Okay, so moving on to part B now, find the greatest height of the ball above the ground, NA. So in this case here, we now know that U is 28. And even if you didn't get part A, you can now do part B, given that you know U is 28, because it says in the question. So we're wanting to do a suvat in the vertical dimension. We want to work out the greatest height. So S is just going to be S. U is going to be 28 over root 2. That's its resolved velocity upwards. V is going to be 0 when it reaches a maximum height, and A is still going to be minus G. So it's going to be V squared equals U squared plus 2AS. So it's going to be 0 squared, that's 0, equals 28 squared, oh I know that's 784 divided by 2, so 784 divided by 2, that's going to be 392, and then it's going to be minus, because we've got the minus g there, 2g times s, so if I move that 2gs onto the other side, and then divide by it, 392 divided by brackets 2 times 9.8, and that gives us 20. So therefore the height above NA is going to be 45. So height equals 45 meters. There we are, that's the answer for part B. Moving on to part C, in a refinement to the model, the motion of the ball from O to A, the effect of air resistance is included. The refined model is used to find a new value for U. How would this new value of U be compared with 28? And give your answer given the value given in part A. Okay, so if we include air resistance and it still needs to reach this point here, then U is going to need to be bigger, because it's going to, the effect of air resistance will be against the, will slow the particle down horizontally, so U will need to be bigger. So air resistance, we might need to write an explanation here, air resistance will slow the particle down so therefore U needs to be greater, needs to be more, needs to be greater. So there we are, that's the answer to part C. And part D is now state one further, that's supposed to be one, state one further refinement of the model that would make the model more realistic. So we've got all sorts of things we'd include. We could include the direction of the wind, so that will either increase the speed of 28 or it will decrease the speed depending upon the direction of the wind. We could use a more accurate value for G, or we could account for there being spin on the ball as well. So any of those answers there, but generally wind direction I think is a good one that will affect the value of U or where it lands. Yeah, so wind direction would be my go for that one. So there we are, that's the answer for question 5 there, a total of 11 marks there. And there we are, that's the answer for, that's all the answers for October 2020 applied paper. I hope you found these videos helpful, and thanks very much for watching everyone.